Gentlemen, this is going to be a short projects update. I have a larger video in the making that has yet to be fully edited regarding the Weisser componentry that was taken off, but at the same time, and I will slightly expound upon it. I'm sorry for casting the shadow, and my back is fucked up because I have been lifting a 80 kilo cast iron surface plate that I had resurfaced, which all in all cost me like 200 bucks. But you can see a huge slab, an automatic collet closer that was removed from this piece in the rear. I'm sorry, I'm trying not to die over here. I was bothering with it for quite some time, being quite unable to decipher how to precisely remove it. What were the end steps was mystifying me. But in the end, I realized that I have to weld up a wrench, let's call it so. This turned out quite square in the end. Doesn't look all that square over here in the shot, but here looks a bit more square and central, which I have actuated with this breaker bar over here. I use the other breaker bar and a slab of steel that you cannot really see but is resting over here, and a piece of wood rested, or rather stacked up over here. The breaker bar is missing the head, as you can see. I inserted it, as this was taken slightly apart, into one of the prongs inside of here, and I used it as a counter lever, merely not to rest it against this edge of the machine, because however capable cast iron is in dealing with compression, I did not want to force that edge to take the brunt of all the forces, because I didn't know how much force I would have to exert on it. So I stacked the piece of wood over here, a chunk of steel to spread out the load across a large area, and the soft wrench handle, which worked against me, but at the same time I rather have things working against me than working against cast iron. Although I should be more considerate about myself and a tad less about cast iron, but I just cannot help myself. Anyway, in the end, I managed to insert this piece into this ring, which is essentially a slotted head screw, well, however you want to call it, and just yank it, undo it from inside of over here, and wiggling things about, I realized that this piece unthreads from the inside. The bore of the lathe is fucking massive. I actually finally believe that the bore is 64 millimeters just by eye, because, well, the Habegger over there has a nameplate that says 64 on it, and such numbers generally refer to the bore diameter. Anyway, that notwithstanding, I have unfortunately, in the process of trying to discover all the end steps, because this was disassembled as part of the discovery, unthreaded, or rather loosened, this bearing retainer back cap. It's not a retainer, it's merely a back cap. But having done that, which was utter and complete idiocy, allowed scum and rust and crap to fall into, well, between the plate and the headstock inside of the bearing, which causes me immense amounts of grief, because now I'm wholly unwilling to rotate the spindle even by a single arc second. And I know that it must have moved at least slightly, and I know that crap must have settled at the bottom of the bearing, of course, inside of the race, because how would it fucking not? It would be really nice if this was a tapered roller bearing, but I do believe that it's a angular contact bearing. So yeah, I've got no idea. If shit fell into it, it's really a bad thing, or rather it's a really bad thing. And more than just that, I have realized that these, you can see a slit over here, there's a bunch of slits. This piece, as you can see, has two pieces, well, two threaded holes that are supposed to be used to pass jacking screws through and to jack this piece away by relying on the bearing back cap. But yeah, given that this back cap was removed, crap fell between the surfaces. I have tried cleaning it out, but I will have to do a much more thorough job before I consider. I will not be tightening it back again. I will merely clean out two sections where the jack screws will be. I will clean them out with a brass wire brush as much as fucking possible, and I will insert two pieces of Teflon or some other extremely soft plastic into there, merely to charge the plastic with any potential remaining grit rather than the cast iron surface, because this is hardened steel and it is going to charge the cast iron spot face essentially on the back side with any potential grit. So two pieces of plastic will be inserted, and they will get charged by any potential remaining crap, and I will use, how do I fucking call it, shock oil to, it's WD-40 powered by liquid butane, so it drops the temperature of shit down to -38 or something like that. But yeah, the point is that this piece actually isn't retained by anything other than essentially spring action. Those slits are springy and are what retains this piece over here. So it is supposed to be merely jacked away, but given that this lathe was unfortunately sitting at the scrapyard for a few days before I saw her, and maybe has seen some rain, which might have creeped into the bearing, which I fucking dread, this piece was likely slightly seized by the rain, or rather by the rust that was generated as a result thereof. It does not really want to go back. I tried gently prying it away against this surface with a pry bar that you can see, and against I put two pieces of wood over here on the thick, well, on the hips of the headstock, lateral sides, and gently tried prying it away, but no go. So I will have to clean out those two spots, insert some Teflon inside, gently tighten the back cap, merely to retain the Teflon in place, and use the jacking screws in conjunction with shock oil to contract the thermal delta, contract the spindle, and I might use nah, that will do. But yeah, I might use a propane torch to heat up this segment, which is not the greatest idea because I'm going to be spraying liquid butane into it, so I'm going to have a fireball going through the spindle. It's not going to harm the spindle in the least, but I'm going to get a face full of fire while doing so. Merely to achieve maximal thermal delta and to allow this piece to be jacked with as little force as possible. I'll most likely insert wrap the Teflon in paper as well, merely to not charge anything with any potential grit that might remain, because once the back cap is loosened, this piece, as you can see, only allows it. I'm sorry, my back hurts as fucking hell and I cannot really bend. Only allows the bearing back cap to move some half an inch essentially, which is not really all that much, not enough to allow me to properly brush everything out of here. So yeah, given that I am aware that crap has fallen into the bearing, and given that I'm aware that these slits go inside of this bearing back cap, I am fully aware that some rain might have found its way into the bearing, which is really fucking bad, because from what you can see, the back cap is fucking immense and the bearing inside of it is fucking immense as well. So it's going to be a really costly bearing to replace, but well, I can go and fuck myself, really. There are no other alternatives, and I have not been all that gentle while I have been trying to remove this piece of fucking shit from the rear, so I might have slightly renelled the front bearing, so I'll have to replace both of them. Yeah, anyways, the lathe is old enough to deserve a new set of bearings, but those are probably gonna cost me 4,000 euros for the rear and front bearing. And that is if the rear and front bearing are only a pair of bearings rather than a dual tandem in the front and a single bearing in the back, or two in the back and two in the front, God knows. But yeah, I could discover more by removing this top cap, which holds the coolant pipe, and seeing how thick the wall inside of the casting is, or rather approximating, because I cannot even guess how thick the bearing is. The bearing could be 3 centimeters thick, so, or it could be 1 centimeter thick. Being a specialized bearing, God knows. But anyway, as you can see, I also have taken apart the Weisser mill. I will be taking her apart even more than I already have. I'll be dragging the rest of her over here. I'll be rotating the Thiel Contorex. Speaking of which, I'm rather interested if Peter Thiel, the infamous, is in any way related to the Thiel family, because I know that Peter Thiel is German, so, but at the same time, Thiel is, well, not really all that common surname in Germany. Still a somewhat common name of my people, so yeah, that's a rather interesting line of thought. But I will rotate the Thiel Contorex. I will plop the base of the Weisser mill over here. I will bring in the column after everything has been ground off of the paint and properly stripped and prepared for painting. And I will slowly assemble her over here and restore all the geometry that will have to be restored. I will try to end the video as soon as possible, because I said this is going to be a short video and it's already almost 15 minutes long, or rather crossing 14th mark. But the Weisser mill is in a pristine condition as much as is possible for a 72-year-old machine. There is some rust that will have to be contended, but that is pretty much most of the wear, or rather tear, on that machine. The lead screws, this central one is from the Mini-lathe. I have also taken her apart because, anyway, that will be touched upon in the video to be edited. But the lead screws, all of them, all three, are nearly intact virgin surfaces. The ways are also essentially intact apart from the rust, and most of the modifications that I will be doing to the machine, which I have covered in that video, are going to be changing the bearing system of the machine for the shafts and the rest of things like gears and stuff, because you can see the gear is bearing with gear steel against cast iron, shafting is bearing against cast iron bores, and none of, however decent of a solution and durable that may be, none of those are a good thing, because once the spot faces and precision bores are worn out, they do not wear evenly. Well, the spot faces might wear more evenly than the bores, but bores wear in an oblong pattern, and they're a fucking bother to restore once they are properly worn out. So while everything is essentially virgin, I will be generating a setup that will allow me to line bore all the bores that I want to a minimal degree. I will be turning the shafts down as well, and I will be inserting needle roller bearings and ball and needle thrust bearings where required to generate proper bearing solutions on both ends of the, well, you get a point. So yeah, I also have the Mini-lathe to restore. I have the Emco to restore eventually. She doesn't really need any restoration, but I may have said it quite some time ago. I have managed to dicker the something inside of the headstock, let's call it that. When I first got the machine, I was cleaning her and I was actuating the head downwards. You can see that the third handle is missing. It's somewhere over here. It's usually where this small screw is, or at least I believe that it is. No, it's not. Yeah, I've got no idea. There might even not be a third handle. I've got fucking no idea. Anyway, one of the handles was facing the table, and I have rammed the head towards the table, ramming the quill actuator against the table, and I have caused something to result in the quill, as you can hear, not really wanting to move for the first few millimeters of the stroke. The rest moves really nicely, as you can see, and returns, but again, returns until that sticky point. I generally avoid. It's not horrible, but it does stick. I have taken this driver gear out and inspected the shit for bending and any potential damage. I have seen nothing with my eye. So I have found a Zeiss metrology piece, a centers fixture that I will use to inspect the shaft. It has two centers for proper, well, properly inspected for bending, but I believe that the driver gear might have bitten the quill rack, or rather the area that is not a rack, might have bitten outside of the rack area, raising a small raised spot, which catches, although that should catch along the whole length rather than in the first few millimeters of the stroke, and if the shaft is bent, it should repeat. So I've got no idea what went wrong, but something definitely went wrong. Although the spindle was slightly sticky to begin with when I first got the machine. So yeah, I'll have to see. So anyway, there's a whole bunch of projects to do. This video has turned into a 20-minute announcement, and I will be cutting it pretty much about now. I believe that I have covered everything. The lathe still has to be dealt with. The Emco has to be properly inspected. There's some scraping to do on the Emco. Yeah, Habegger. All the rest of the things you pretty much know. I will not be touching upon the Elb surface grinder, the Charmiel, nor on the Scherer lathe, because those are projects that are far too demanding of time investment. So they will have to wait and merely be doused in oil or grease, depending on how often I plan on protecting them from rust. The Schaublin unfortunately is still sitting under covers, also getting oiled regularly, because I have got, as said, no intention of using her until I have taken literally everything apart and changed the grease. As you can see, the top of Kluber grease over there. In the spindle bearings, re-greased the bearings in the gearbox, re-greased all the bearings in literally everything, which is pretty much almost 100 fucking bearings in the whole machine, because every shaft has at least 2, if not 4, bearings to clean and re-grease. So yeah, I'll pretty much shut up now. I bid you all the best, and as said, I hope that I covered everything. So until I post the video that expounds on these and shows a bit more of these components, I bid you all the best, and yeah, bye bye, see ya.